Good morning, sixth grade science, and welcome to Wednesday's lesson. As a review, yesterday we talked about two different types of energy. Who remembers what it's called? Yes, Connor? Good try. You got one of them. That's right. It's potential energy and kinetic energy. Remember, potential energy is that energy, that stored up energy that's ready to go based on its location. And we have our kinetic energy, where it's energy in motion. So if I had that car and I push it over the edge, it's energy in motion. Now, potential and kinetic energy are forms of what we call mechanical energy. Who remembers what mechanical energy is? Right, it's the ability to make something move. So if I had, our cars would be a type of mechanical energy where we have gears and belts and all that get our car to move. Our bodies, remember we talked about how we change forms of energy all the time. Like our bodies can do that when we convert the chemical energy of food into the ability to move. It gives us energy to move. We use electrical energy in order to move motors, help us perform tasks. We also use machines to increase force of mechanical energy. So we use some simple machines like levers in order to make our everyday lives a little bit simpler. So what exactly is motion again? Motion, it is the change of an object's position, something moving from point A to point B. Now, in order to determine whether an object has changed position, we need something that's fixed and unmoving, or a location to use as what we call a reference point. And let's think of it this way. How many of you have a growth chart on the wall in your homes? Something that your parents have used since you were a little baby to figure out how tall you are and how fast you've grown. That chart is a type of reference point. So what would be some characteristics of that reference point? What do you think? Right, it's unmoving. It would be kind of cheating if you went up to your growth chart and you kind of lowered the chart a little bit to make yourself look taller. I know some of you are tempted to. So the growth chart, it's a fixed, unmoving thing. It does not change. It stays at the same height the whole time. Why is that important? Right, it's important because we need to have an accurate assessment of how tall you really are. And if we changed the height of that growth chart, it wouldn't be a valid test result. We would be cheating ourselves on our height, whether it made us taller or shorter. What are some other reference points that you have seen or used? Possible answers. How many of you have flown on a plane? When it's coming in for a landing, there's a lights on the runway to tell the pilot where they need to land. It would be super dangerous and unfair to everyone on the plane if those lights constantly were moving back and forth or around and they weren't fixed and made the pilot kind of guess where he needed to land. Another reference point, the finish line of a race. If you have ever run a race, you know that there is one spot at the end that you need to cross in order to finish the race. Again, it would be unfair if someone had that finish line and kept moving as you were trying to finish. What about for those of you that shoot guns or archery, the target, right? That would be a reference point. A lighthouse, a basketball hoop, a soccer goal, those are all reference points. They're fixed, unmoving locations. A reference point is something that always remains still. So let's think about it this way. If we need to know that motion, something is in motion, we have to have a reference point. Go outside at some point and I want you to look up into the sky. Hopefully there's some clouds out there. And I want you to kind of put blinders on your eyes so that you only see the clouds, okay? Make it big enough so that your hands aren't that reference point, but I want you to look up into the air and I want you to see if you can tell if those clouds are moving. Sometimes it's hard for us to tell if a plane way off in the distance is moving unless we had some sort of reference point. Usually our reference points are trees or buildings or things that are unmoving. Let's think about it this way. If you ride in a car, you can tell it is moving because you can see its position changing in relation to the stationary objects that are outside of that car. Like what? The trees again, buildings. You can see the yellow lines in the road passing by as you're going by. But if you look at the person that's inside the car with you, they look like they're not moving at all, even though they are. The reference point inside the car is not fixed because that car is what? That's right, it's moving. So the person in the car is moving as the car moves. So what would I have to look at in order to understand that the person next to me is in motion, or that I myself am in motion in that car? That's right, I would be looking at what is outside my window. At night, when it's hard to see reference points outside the car, another car's headlights way off in the distance can be very confusing. Is the other car still? Is it moving, coming at you? Next time you're driving outside at night, or not you driving, hopefully you're not yet, when your parents are driving or an older sibling and it's nighttime, I want you to look off in the distance if you see a car coming with their headlights on. It's very hard to tell how fast that car is moving. Why? Because there's no reference points to tell us visually if that car is moving fast, if it's even moving at all. So a reference point, again, is that fixed, unmoving object or location that tells me that something is in motion.